Hello, Midnight Coders, and welcome to another episode of the Midnight Coder. So I've had a login page. I'm secure, right? Imagine launching a brand new business and every single door is unlocked. Admin board rooms, client records, internal documents. There are no roles, no restrictions. That's not a feature. That's an unlocked front door. Real security starts with how users authenticate, what they're allowed to access, how passwords are stored when things go wrong. So, make sure you've got that full cup of coffee, and let's dive on in. When a viewer comes to our website, we don't want them seeing everything or doing whatever they feel as if they own the place. We want them to be logged in. And more than that, we want roles. We need a way to control who can access what section. So, how registration works: a user first fills out a form. The backend then validates the input. Passwords are hashed before saving, and the new user record is then stored into the database. As for the login flow, a user will send their email and password. Spring Security will load up the user details from the database. Provided password is then hashed and then checked against the stored hash of that user. If everything's okay, then Spring Security will create an authenticated session. And if not, the user is just sent back to the login page with an error. Only authenticated requests can access certain endpoints. All others will be redirected to the login page. This class is our security configuration. This is marked with configuration annotations, so Spring can pick it up. This chain defines a few things: which URLs are public, which URLs are private, requiring authentication, and what the login page is, and where to go on a successful login, as well as the logout behavior. In here, we can see that our requests for authentication and for registering are permitted by all cost or at all time. Any requests of type GET that come to the home page or the resources are all permitted. If anybody tries to make anything else other than a GET to any of these, they will require authentication, as any other request gets authenticated. We tell it that we have a form login and that the login page is at domain/login. And a successful login is going to take us back to the home page with a successful login flag. And of course, the login configuration allows us to log out. When we store our users' information, we only store the bare minimum: an ID that is generated, the nickname or username, and email address that are provided, and the password is hashed. Rule number one about passwords: you should never be able to recover a password, ever. Encoding, encryption, and hashing. These are all terms that are often used interchangeably by junior developers, but they solve very different problems. Encoding. Encoding is not for security. Encoding is a reversible transformation of data into another format. No secret involved. Some of the examples of this are base64 and URL encoding. The purpose of this is for data compatibility, transport, or storage. If you can decode it without a secret, it's not secure. Anyone that gets an encoded value can instantly reverse it. Encoding offers zero protection. Now, encryption is for security, but it's still not for passwords. So, what is encryption? Encryption is a reversible transformation using a secret key. You can encrypt, and decrypt. Examples of this are AES and RSA. Their purpose is to protect data that must be recovered later, such as credit card numbers, API tokens, or private documents. So, why is this still wrong for passwords? Your system holds the key. So, if your system is breached, the attacker then gets the encrypted password and the decryption key. Result: everything's exposed. So, if your app needs to decrypt a password, then your design is already broken. So now hashing. What is hashing? Hashing is a one-way transformation that you cannot reverse. Same input is going to get you the same output. We use things like BCrypt and Argon 2 because these verify identity without knowing any secrets. So how does a login actually work? User enters their password, and then we hash that password. I compare that hash with the hash of the stored value, and if they match, it's authenticated. You should never see the password or store the password. Hashing. We generally use slow hashing algorithms because fast hashes are dangerous. Attackers love fast hashes. Modern password hashing algorithms are intentionally slow and intentionally CPU and memory heavy. Why, you may ask? This slows down the brute force attacks of somebody that may have breached, and it makes GPU attacks a lot less effective. So for this, we use BCrypt or Argon 2. So why does all this even matter in the first place? When a company gets breached, best case is that only password hashes are leaked. And if a company is quick enough to notify you, you have time to react and reset your passwords, hopefully before someone tries to get in. And if we have this slow hash in play, it really slows down the attacker's momentum. Registration. When the registration DTO comes in, a GET request to /register will return an HTML page. A POST to the same URL should provide form data in the shape of a DTO. And this is to fulfill the request. When a login request DTO comes in, a post to the auth login should provide form data in the shape of a DTO as well, be able to verify the request access. We have configured the login page path and successful page path. Spring will bind the email and password from the request to the authentication process. When a user comes to our page, how can we make sure that they're protected? Well, if I try to go to a page to which we do not have access to, we'll be redirected to the login page. So if I come up here and try to go to profile, I get redirected to a login page. Where if I log in, so now if I log in, I am greeted. And if I try to go to the profile page, now I am greeted with my profile. So you'll also notice that logged out or not, the resources are still there. The image floating on the website, CSS, JavaScript that is running. This is due to the setting in our security fig that we talked about earlier. And right now, we have session-based logins. So when I leave the page, the system still keeps your session alive unless you specifically hit that logout button. Once you log out, Spring will invalidate the session, clear the authentication, and redirect us to the login page. So today we wired up real authentication with Spring Security. Registration, login, session, and role-based access control. We broke down how passwords are handled securely using hashing, why encoding and encryption don't belong with authentication, and how Spring protects pages behind a login. So at this point, our app knows who the user is, what they can access, and how to keep their credentials safe. However, right now, our application relies on server-sided sessions, which works, but only as long as everything lives in one place. So in the next episode, we are going to move beyond the sessions and we are going to introduce JWTs, or JSON Web Tokens, also commonly known as JOTs. We're also going to introduce refresh tokens so that our authentication works without the server remembering who you are. So if you've made it this far, thank you very much for watching. I hope that you've learned something. You can hit that like button if you did. And remember to hit that subscribe button. Turn on notifications so that you get notified when I post the next episode. If you happen to have a friend that might find this series useful, remember to share it with them, as it helps us reach more developers. And as always, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.